Okay, without wasting time, we'll start the class. Okay, let others will join the class. Okay, in the last class, actually, I was discussing about the POP3, IMAP. So the POP3 and IMAP, it is nothing but it is those are said to be the application layer protocol. So like your HTTP and FTP, even SMTP, it is for especially mail transfer. You have SMTP, POP3, that is post office protocol. Okay, and then IMAP, that is Internet Message Access Protocol. So those protocols we have discussed and we have seen the differences between the SMTP, and there is some drawback in SMTP. So in order to overcome that, we have gone through the POP3, and then to overcome some of the drawbacks in POP3, we have seen the IMAP. Okay. And also I was discussing about the DNS, that is the domain name system. So why you require a domain name system or domain name server protocol? It is because to map your host name to the IP address. Okay. So I was briefing about the domain name system. So before going to the domain name system, actually I was about to explain a scenario where we have seen the web proxy server, or we can also call it as the web cache. So what do you mean by web cache? Web cache. Okay, we have seen you should be interactive. So everyone should be interactive and everyone should listen and respond to the class. Okay. So web cache, it is nothing but just in order to interact, the client is going to interact in order to communicate, or to access a file, or in order to access any object with respect to image, video, text, file content, anything. He need to access the server. That is the origin server or original server, where actually the content or everything is located. So but in the middle we have the web cache in order to overcome. So this is the architecture that we have seen. So in order to reduce the response time, in order to reduce the traffic, so usually the clients will be densely populated, so it is very difficult for a single server to provide the responses or to satisfy the request within a short span of time and all. So that's why we have seen the concept called as web cache. Okay, so here we have a scenario. So web cache is nothing but, so whatever the files initially you're going to fetch, you have to fetch from the origin server. So later one copy of that data will be kept in the web cache, like your cache in your system, how it's going to work. There will be a cache between your main memory as well as the user one who want to fetch the content from the main memory. Usually frequently accessed instructions will be kept in the cache. In the same way, some content you'll be accessing, or the content you'll be accessing from your server, origin server or the original server, that will be kept in one copy, will be kept in the proxy. But the thing is, every time it has to be keep on updating itself, or else whenever the user contacts the proxy server or the web cache, so the content it has to fetch from the content it has to. Is it audible, students?
Yes, ma'am.
Okay, the contents it has to fetch from the proxy server. Only if it is not available, only if the proxy server is not updated, only if your web cache is not updated, then you have to go and fetch the content from the origin server. So that's how it is going to work. So now we'll discuss a problem or a scenario or a case study with respect to the web cache. What happens if web cache doesn't exist, and what happens if web cache exists? So that is the scenario we are going to learn today. Okay, so here we have to do some assumptions. So here there is a scenario. This is a default scenario where the public internet will be there. So through the public internet, you are going to access the origin server. Okay, and there is a one more network called as the institutional network. Institutional network, where actually the client, or for example, we have an institutional network called as Savidya Institute of Technology. You have a network. Okay, you're going to maintain a network. So in your network, you'll be having the router, all the clients, okay, all the systems or all the users or the clients. So they will be connected to this particular router. Okay, and then so in between these router, one router will be maintained at the institutional network, another router will be maintained at the public network, in order to find the path where actually the destination exists, where actually the server exists, or where actually the client exists. So in order to find the path, we'll be having the router. Okay, and then So origin service is located in the public network, and the client, those who want to access the content, it will be located in the institutional network, for example, Savidya IT network. Okay, and then so here whatever the access link rate it is there, so that is 1.54 megabits per second. Okay, so that is 1.54 megabits per second. Okay, and then for the LAN, so for your local area network, it is about 10 megabits per second. So here we have some assumptions. We have made some assumptions. Okay, so what is the average object size? Means suppose if you want to access any object, so each object, it may be a file, it may be an image, it may be a video, or it may be a file content, anything that you want to access from the origin server. Okay, so here you have only the origin server and the client. There is no any web cache or anything. Okay, this is by default traditional network, how actually it works without the web cache. Okay, the average object size, it is 100 kilobits. Okay, means the content or the image size or the content size or the file size. Let us think it's a file. So it is about 100 kilobits. Okay, and average request rate from browser to the origin server means that browser is nothing but the web browser, means the client when he need to make a request. So what is the request rate? So in a second, so how many requests can be sent? So that is defined as the average request rate. So average request rate, it is given by 15 requests per second, means from the institution network. So it is able to provide 15 requests, means in a second it is able to send 15 requests. 15 requests can be sent per second. This is the average request rate. And then HTTP request messages are small. So usually whatever the protocol you're going to use, it is said to be the HTTP protocol. And the request and response will be treated as HTTP request and HTTP response. Okay. And then average data rate to the browser means average data rate to the browser means the data rate is nothing but number of bits transmitted per unit of time or per second, okay, to and fro from the browser. So that is given by 1.50 megabits per second. So this is the data rate, average data rate at the browser. So it is able to receive is about 1.50 megabits per second. So that is the data rate it is able to receive, means your web browser, it is able to receive from the server, it is about 1.50 megabits per second. And here you have the internet delay. So usually what do you mean by the internet delay? So actually there is three different types of delay. So that is nothing but the LAN delay, access delay, and the internet delay. So the LAN delay is nothing but in your network. So usually all the systems that is connected in a LAN, that is local area network. So in this LAN, so usually some delays will be there while sending and receiving or while accessing your devices or your system. So usually a small delay will be there. So the delay at the local area network, okay, that is called as LAN delay. And then access delay, there is one more delay called as access delay. So access delay, it is nothing but the delay between the routers, the delay between the routers. So that is called as the access delay. Please note down. So this is very important. And internet delay. So internet delay, it is nothing but the delay between the routers and the internet. Like for example, if you have a home network, so you'll be the router in your home network, and then you need to access the internet from the outside world. Okay, like for example, it may be ACT or like ACT. So that is one of the service provider. So that is the delay. So that is the internet delay. It is nothing but it is the delay between the routers and the internet. All of you keep in mind, LAN delay, that is the delay that occurs within your local area network. Access delay, this is the delay between the routers, and internet delay, it is between the routers and the internet. Okay, because with the help of internet itself you can access the outside world. Okay, so that is the internet delay. So the internet delay, it is given by 2 seconds. Internet delay, it is given by 2 seconds. Okay, and then access link rate. So what do you mean by this access link rate? So this is nothing but the maximum speed, the maximum it is the maximum speed that data can move across the wireless link between the wireless client and a wireless router. Okay, so here you'll be having the routers between the client and the client as well as the server. Okay, usually these routers are connected through the access link. So what is the maximum speed the data can move across this wireless link between these routers? Okay, that is nothing but the access link rate, means the number of bits transmitted per second on the link that is connected between the clients as well as the server's router. Okay, the link that is connected between the client as well as the server router. Okay, that is called as the access link, and that rate is given by 1.54 megabits per second. Okay, don't get confused. So the object size is whichever the file or the content that you want to transmit or receive from the server, so that size. And request rate is nothing but, so how many requests can be sent from the client per second. And usually whatever the messages that you are sending, HTTP request messages, so these are generally treated as small messages where traffic should not occur, assumption that we have made. And then average data rate to the browser, means the browser is able to receive the data at the rate of 1.50 megabits per second. Okay, and the internet delay, means the delay between the router and the internet, it is given by 2 seconds. We can also call it as the round trip time. Okay, and the access link rate, means this is your access link that is existing between the client and the server router. So that is about 1.54 megabits per second. Okay, now we should know what is the LAN utilization, what is the access link utilization, or we can also call it as the total delay. Okay, so the LAN utilization is only 15%. So the LAN utilization, in the sense the delay with respect to local area network, or we can also call it as the traffic density at local area network. So in order to know this LAN utilization or the access link utilization, you should know what is the traffic density at local area, not density, intensity. What is the traffic intensity at local area network and the access link utilization? Okay, so here you have a formula, traffic intensity. So it's not in the textbook directly, they have given this calculation. So but how to calculate? So we have a formula called as A into L divided by R. So the traffic intensity, this is a general formula to calculate the traffic intensity in the network. Okay, so the traffic intensity in the local area network or the traffic intensity in case of access link. So what is the traffic intensity? So that is given by A into L divided by R, where A indicates the average arrival rate of packets. Average arrival rate of packets. So usually how many packets you are sending, it depends on the number of requests, the requests that you are doing. Suppose if there is 15 requests, then 15 packets per second, like that. Okay, so that is the average arrival rate of packets. So what is the average, how many number of requests that you're going to send through your link? So that is nothing but average arrival rate of packets. And then, so average packet length. So usually what is the object size? So whichever the object that you're going to send or receive, so what is the object, each object length? So average, we have taken it as the 1 megabits per second. And what is the transmission rate? What is the transmission rate? So that is nothing but R indicates the transmission rate. So here for the local area network, so the average arrival rate of the packets, it is about 15 requests per second, means we are sending 15 requests per second into L. This is nothing but the packet length. The object length we are considering as 1 megabits per request, means each request it is going to carry 1 megabits. Okay, that is the packet length that is given by the packet length. Each packet is going to carry 1 megabits. Okay, divided by R. So what is the transmission rate in the local area network that is able to provide is 100 megabits per second. It is able to transmit 100 megabits per second. So traffic intensity at the local area network, it is given by 0.15. So if you calculate this, you are going to get 0.15. So if we convert into percentage, for identifying the land utilization. So it is about 15%. Students, are you with me?
Yes, ma'am.
Okay.
Yes,
Are you
ma'am.
understanding? Are you getting?
Yes, ma'am. Yes, ma'am.
Yes. Even others should reply. Suppose if you have any doubt, you can ask me here itself. Okay. So the transmission rate, it is nothing but, so 100 megabits can be transmitted per second in the local area network. So after calculating this, we are going to get 0.15 as the traffic intensity. Okay, traffic intensity. Okay, that is about 15% land utilization. So traffic intensity, it is directly proportional to this land utilization. So it is about 15%. Okay, and then the access link, in the same way we have to calculate for the access link. Access link, see here, you can see this is the access link, and this is your local area network. So the local area network, the traffic intensity is about 0.15, that is only 15%. But if you consider the access link again, so how many requests you are able to send? 15 requests per second. So the each request is of about 1 megabits per 1 megabits, okay, for each request. So that's why the length is only 1 megabits. Okay, and then so whole divided by 1.54 megabits per second, because this is the access link rate. Access link transmission rate, it is about 1.54 megabits per second. Okay, so that's why it is specified as 1.54 megabits per second. So at last you are going to get 9.7. You are going to get 9.7 as the traffic intensity in case of access link. So that indicates how much traffic. Okay, where the access link utilization, if you convert it into percentage, you are going to get the access link utilization. It is about 97%. Okay, so just go through this formula, all of you, after explanation, just go through this formula, just go through the slide. I will share the slides, and then if you have any doubts, again you can contact me. Even this is given in the textbook, but the formula is not there. This is the formula that you have to apply. If you want, you can note down. Okay, so we'll go back to the same slide. Okay, now the land utilization, after calculating the traffic intensity, you will come to know the land utilization. So it is about 15%. Okay, and then access link utilization. Access link utilization, it is given by the 97%. So this utilization indicates the delay or due to the traffic. Okay, on in case of local area network, there is only 15% delay will be there, where in case of access link utilization there will be 97% of delay, where the total delay it is given by internet delay, access delay, and the land delay. Internet delay, access delay, and the land delay together, we are going to get the total delay. I already told that the internet delay is nothing but the delay between the router and the internet, where access delay it is given by the delay between the routers. See here, the routers that is existing between the client and the server. Okay, this is the delay between the routers, and the land delay is nothing but the delay with respect to your local area network. Okay, so that's what we have calculated here. That's what we have calculated here. You can see. So the land delay it is about 0.15 and access link delay it is about 9.7. Okay. So 9.7, that is with respect to minutes. That is with respect to minutes. And okay. Now here you can see the total delay you can calculate. The internet delay already they have given, means between the router and the internet that you want to access. So it is about 2 seconds. It is about 2 seconds. And with respect to the access delay, it is given by 9.7. That is with respect to the, see here, this is the access link delay or due to the traffic intensity. So the delay is going to occur where it is about 9.7, which is approximately equal to 1 in the sense. So where it needs a minutes, means a minutes of delay will be there. where a minutes of delay will be there. So 9.7, it is approximately equal to 1. So where about 1 minute of delay, like means the delay where it will be considered in terms of minutes, it will be there. But if we consider the local area network, it is about just 0.15. Already we have calculated the traffic intensity, it is about 0.15 seconds. So that is also we are going to consider it as the delay. That is 0.15 seconds. We can consider it as the U seconds. It is said to be the negligible because U seconds indicates it is a microsecond. So microsecond. So in the Unicode language, we can also represent the like this. U. Okay. The microseconds to milliseconds, where the delay in case of local area network, it is very negligible. It is said to be negligible. So that's why it is represented 2 seconds already. The internet delay, it is already known. It is about 2 seconds, where 9.7 or 9.7, that is the access delay, which is approximately equal to 1, where it will be with respect to minutes. But with respect to the LAN utilization, that is the LAN delay, it is said to be negligible. It will be in terms of microseconds to milliseconds. Okay. So now we'll see that there is a problem. There is a problem in case of access link utilization. There is a problem. See here, there is a problem with respect to the access link utilization or the traffic intensity with respect to access link, or a delay with respect to access link, where it is about 97%. It is too high. It should not be that much. Okay, so that's why we have to, how we can reduce the access link utilization. So that is very important. How we can reduce the traffic intensity in the access link. Usually the traffic will be there in the access link because the multiple clients, they are interacting with the server. So how we can decrease this access link traffic intensity is by increasing the access link rate. By increasing the access, one solution is by increasing the access link rate, we can decrease this access link utilization. Okay, so now access link rate is about 1.54 megabits per second. It is 1.54 megabits per second. This is also one reason where the traffic density, traffic intensity is too high. It is about 97%. Okay, so we can decrease the access link utilization. Only one solution. One solution is by increasing the access rate, by increasing the access link rate. So initially the access link rate, it was about 1.54 megabits per second. So what it says, fatter your access link, means expand your access link, increase the access link rate. Okay, so that your access link utilization, in the sense traffic intensity, in the sense delay, you can reduce the delay. Okay, if you increase the access link rate, automatically, if you apply the formula, whatever I have given here, whatever I have given here, instead of 1.54 megabits per second, if you give as 154 megabits per second, automatically it will become 0.97. It will become 0.97. Okay, 0.97. Okay, okay, we have seen here, since it is a fatter access link, so one solution to here, the main goal is to reduce your access link utilization. So how is one solution is to increase your access link rate. Now I have increased the access link rate from 1.54 megabits per second to 154 megabits per second. So everything else remains the same as in your default scenario. Okay, so after increasing your 1.54 megabits per second access link rate to 154 megabits per second, so the now access link utilization will be reduced to 0.97%. It will be reduced to 0.97%. Okay, so initially the LAN utilization 15%, it remains the same only with respect to access link rate. So if you increase the access link rate, so you can decrease the access link utilization. So at that particular time, so your internet delay will be 2 seconds as usual, that is by default, but your access delay what it was in terms of minutes. Now it will be reduced to in terms of microseconds or milliseconds. So that is indicated by this U seconds. So this indicates the microseconds. So now the delay at the access will be reduced. But there is a drawback. Here, if we increase the access link rate, indicates here it is not cheap, it is too costly. If you increase this particular access link rate, it indicates that so there is increase in the cost, but it is too costly to provide the maximum speed. Means 154 megabits per second. So the bandwidth should be high. Okay, so the network resources, whatever you're using, so you have to use in an effective manner such that you have to give the higher bandwidth. Higher bandwidth is required in order to increase the speed of your access link or the rate of your access link. So increased access link. Okay, so we have to see or we have to find one more solution. Okay, what's the solution? So that the access link utilization should be reduced, as well as we should not fatter the access link. Means it should be 1.54 megabits per second. We should not increase the speed of the access link, but we should reduce the access link utilization or the delay. How it is possible? So it is possible by using the local cache. Okay, so see here, you are going to use the local web cache here. So assumptions as same as your this thing, what it was, 100 kilobits per object size, and data rated to the browser it was about 15 megabits per second. So like that, this same assumptions will be kept. 15 requests per second will be there. Data rate to the browser will be 1.50 megabits per second, and internet delay 2 seconds. Access link rate it is 1.54 megabits per second. But the thing is, here we have to see that it should be reduced. The access link utilization should be reduced. Before it was 97%. In the first solution, so this was the problem. In the first solution, what we did, the we have increased the access link rate to 154 megabits per second. So that's why access link utilization, it has been reduced to 0.97%, and now the access delay, it was reduced to microseconds. But here it is too costly. So to overcome that, we are going to use the local web cache. So now, so the LAN utilization, it already exists. It is about 15%. Okay. But what about the access link utilization? And the web cache is said to be cheap. Usually, if you have a good local area network for your organization, you can keep your local web cache. So whatever the files that comes from the server, usually you can keep a copy of that in your local web cache that is connected to your institutional network. This is very cheap compared to the access link, increase in the access link rate. Okay. So how to calculate this access link utilization? Okay, how to compute the utilization or the delay? So now, here there is a local web cache in your institutional network. So how to calculate? Suppose the cache hit ratio is 0.4. So what do you mean by this cache hit ratio? Means it indicates how much percentage the user has referred the cache instead of going to the origin server. Usually a request will be made. So only if the proxy server doesn't contain, initially it is going to fetch the data from the origin server, and then it's going to keep a copy in the proxy server. So every time if a client or the user needs a file content, so what he's going to do, he's going to fetch from the proxy server. Okay, so means instead of going every time and asking for the origin server for a content, so here almost 40% you're going to refer this proxy server, where only 60% you're going to request from the origin server. So that is nothing but the cache hit ratio. Means the number of times you're going to refer or you're going to fetch the content from the cache. So that is nothing but the cache hit rate. Okay, it is about 40%. We have made some assumption that 40% has the request has been satisfied by the cache compared to the origin server, where origin server hit ratio or origin server hit ratio, it is given by 60%. Now we'll calculate. Okay, so that is 60% of the request use the access link. Only 60% you have to use this access link. Okay, because the 40% you're going to access from the proxy server where it is existing in your local area network. Okay, and the data rate to the browser where the browser is going to fetch the content from the origin server. So it is given by already the data rate to the browser, it is given by 1.50 megabits per second. Suppose if you want to access 60%, that is about 0.6. 0.6 is nothing but 60% you're going to fetch from the origin server. So that is given by 0.6 into 1.50 every time for each request. So 1.50 megabits per second. So that is the rate, data rate at the browser. So you're going to get 0.9 megabits per second. 0.9 megabits per second. So now if we calculate the access link utilization, it is given by 0.9 megabits per second. So that is 60% hit ratio divided by 1.54. That is the access link value. The access link rate, it is given by 1.54. So 0.9 divided by 1.54, you're going to get 58%. Just in order to convert into percentage, you're going to multiply it by 100. So it is given by 58%. Okay, so since only 60% of the request you are going to use the access link, so it is treated as 0.6 into the data rate at the browser, because through the browser itself you want to access the origin server. So here you're going to enter the data, that browser is going to contact the server. Okay, so that is the time, that is the rate it is given by, the data rate at the browser or to the browser, it is given by 1.50 megabits per second into 60% of the request is going to use the link. So that's why 0.6 into 1.50 megabits per second is given by 0.9 megabits per second. Now how we can calculate the access link utilization? So it is given by the data rate at the browser for 60% of the request divided by the access link value. Access link rate value. Data rate to the browser divided by access link rate value. That is given by 0.9 divided by 1.54 into 100. Since we have to convert into percentage, you're going to get only 58%. Before, how much it was? It was about 97%. It was about 97%. So here you can see in case of the default scenario, it was about 97%. Okay. Later it was reduced to 0.97%. But now it has been reduced to 58%. Okay. So now the total delay it is given by 0.6. That is, we have 60% as well as the 40%. 60% from the origin server and 40% from the cache. So the total delay. So one with respect to the request that you are satisfying at the local cache, and the other 60% it is satisfying by the origin server. So for that we have to calculate the delay. So 0.6 into delay from the origin server, and then 0.4 into delay when satisfied at the cache. Okay, so 0.6 into 2.01 seconds for access link and the LAN. Okay, so the local area network, it is able to satisfy all the requests, that is 15 requests in 10 milliseconds itself. 10 milliseconds. So that assumption we have made. If suppose the local area network is able to satisfy all the requests in 10 milliseconds, then it is given by 0.4 into 0.01 seconds for local area network, where 60% you have to fetch the content from the origin server, that is given by 0.6 into 2.01. 2 is nothing but the internet delay plus 0.01. You have to check in the local web cache. First you have to check in the local web cache. So that is given by 0.01 plus the internet delay that is given by 2 seconds. So 2 plus 0.01, that is 10 milliseconds, is converted to seconds. So we are going to get 0.01 second. So that is given by 2.01. 2 for internet delay and 0.01 for the LAN delay. Total together we are going to get 2.01. So 0.6 into 2.01 plus 0.4 into 0.01 seconds. So you're going to get approximately as 1.2 seconds, where it is less than with respect to 154 megabits per second the link. This is very cheaper. Means with this scenario, what it says is, so compare the contents. If you're going to fetch the contents every time from the origin server, so the response time will be too high. Okay, and the network resources will be accessed, even you have to pay for that. So we have seen it was too costly. Suppose if the access link rate has been increased, that is one thing, and the traffic will be reduced. So here within 1.2 seconds itself, so all the 15 requests can be satisfied with the help of the origin server and the local web cache server. All of you understood this? Just this is a scenario. This is one case study. What happens if local cache exists? What happens if local cache doesn't exist? And what happens if there is no local cache but there is an increase in the access link rate? Just it's a comparison. Okay, to know if you have a local cache, we'll be having the better efficiency so that the response time will be reduced to just 1.2 seconds. That's it. All of you understood this concept? Students? Students? Hello?
Yes, ma'am.
Yes, ma'am.
All of you understood this concept?
Yes, ma'am.
Okay. Okay, students. So just I'll send the client slides after the completion of this module. Just go through it. Okay. And then again, if you have any doubt, so you can ask me. I already have shared the textbook. You go through the textbook. Okay. And then if you have doubt, you can ask me. Okay. So now,
Okay, ma'am.
due to exam duty, I'll be leaving the class. Okay. All of you can leave. Okay. Just a minute. I'll just take the attendance. Just a minute, I'll take the attendance. Okay. Okay, thank you, students. Thank you very much. Okay, have a good day. Just go through the problem. Again, if you have any doubt, you can ask me.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you. You can leave the class.
Thank you, ma'am.